In this video, we're going to find the limit as x approaches 0 of tangent x minus x over x cubed. So the first method we're going to use is just using L'Hopital's rule 3 times. So first time, we're just going to take the derivative of the top and the bottom. So just take the derivative of the numerator. The derivative of tangent of x is secant squared x, and then derivative of x is just 1. Derivative of the denominator, drop the exponent, so 3x squared. So that's just going to be, and then we can use the Pythagorean identity for secant squared x minus 1. We know that that equals tangent squared x. So after one time using L'Hopital's rule, we get tangent squared x over 3x squared. And then we're going to take the derivative of both the numerator and denominator here again. So derivative of tangent of x is going to be, we're going to use the chain rule, so we can drop the exponent, so that's going to be 2 times tangent of x, and then multiplied by by the derivative of just tangent of x, and we already did that up here. We know that's secant squared x. So for the numerator, we got 2 times tangent of x times secant squared x, and then the denominator, drop the exponent, so we got 6x. And then we still have x in the denominator, so that doesn't work when x is 0, so we need to do it the L'Hopital's rule one more time. And then we get the derivative of 2 times tangent of x times secant squared x is going to be a little bit trickier to take. We have to use the multiplication rule. So just take the 2 out in front, and then we'll do all the other stuff. So derivative of tangent of x times secant x plus the derivative of secant x times tangent x. So that's going to be, we know the derivative of tangent x is secant squared x. So then we'll have secant squared x times secant squared x plus the derivative of secant squared x is, we got to use the chain rule here. So drop the exponent, we got 2 times secant squared x, and then multiply by the derivative of secant x, which is tangent x, and then we have times another tangent x, so that's going to be tangent squared x here. So then 2 times all of that. So then we can combine some like terms here. So we get 2 times in parentheses secant to the 4th x plus 2 times secant squared x tangent squared x. And then multiply the 2 out. That's easy. We just got 2 times secant to the 4th x plus 4 times secant squared x tangent squared x all over. Oh yeah, and then I forgot, we got to take the derivative of 6x, and that's just going to be 6. So that's going to be in the denominator here. So now, since we don't have a 0 in the denominator, we can actually take the limit and plug in these zeros here. So when secant of 0 is always going to be 1, so we can just plug 0 in for secants, and we get 2 times in parentheses 1 plus 4 times 1 times 0. And that's just going to be 2 times 1, so that's 2. 2 over 6, and 1/3 is the answer for the limit. And then there's another method we can use where we use the approximation of the series for tangent x. So using the first 3 terms for the series that represents tangent x, so that's going to be x plus x cubed over 3 plus 2/15 x to the 5th. So I'm just going to plug all of these 3 terms in for tangent of x into this, into the limit here. So we get the limit as x approaches 0 of x plus x cubed over 3 plus 2/15 x to the 5th minus x. So then over x cubed, x's cancel, so then we just have these 2 terms, x cubed over 3 plus 2/15 x to the 5th over x cubed. So since we got x's in the denominator, we need to use L'Hopital's rule again. So then we can do, take the derivative of the numerator, so drop the exponent, that's going to be 3 over 3 times x squared, so that's just x squared, and then 10 over 15 x to the fourth, that's just 2/3 x to the fourth over 3x squared. Then we got to do it again, so then we get 2x plus, drop the exponent, that's going to be 4 times 2 over 3x cubed, 8/3 x cubed, all over 2 times 3x, so that's 6x, and then we'll do it one last time, and that leaves us with 2 plus 8x squared over 6, and we don't have an x in the denominator now, so we can actually take the limit. So plug in 0 for x here, and we get this 8x squared term just is 0, so then we get 2 over 6, 1/3. Boom. And these are the same answers, so definitely know that's right.